right, so let's just go through this relative mass in the mole worksheet. How can atoms be counted? Why do we look at these? Hopefully this analogy helps you to sort of take in the concept of the mole. Go ahead and take a second and just read the paragraph that's in front of you. Okay, so the last sentence says weighing is often easier than counting. Now, eggs we can count if we need to, but atoms it would be absolutely impossible to count them. So in this case, that's why we are using the weighing. So let's look at the analogy that they're making here. If we look at the data table there, it says model 1 eggs. Number of eggs in the sample. If we have one chicken egg, its mass is 37.44 grams. Okay, what do we need to do to find 10 chicken eggs? Yeah, we're gonna multiply. We're gonna multiply that. So we pull in a calculator. We pull in a calculator and we just say 10 times 37.44 equals, well, you guys probably could have done that in your head, but 374.4, and then we're just going to type it in there. Or write it in your data table. Right? So this is, you guys probably could go through and fill in the data table for the chicken eggs and the quail eggs, and then we'll talk about the ratio here in a second. So I'm going to do this if you want to just follow along, but if you'd like to go faster than me, that's fine too. So if I look at 438, I'm going to take 438 times 37.44. I'm going to get 16,398. I'm going to do a dozen, which is 12. So 12 times 37.44 equals 449.28. And then a million eggs. Well, that's a lot of eggs. But still 37.44 times a million, which you all could probably just do that in your head by moving the decimal place. And then we're just going to go ahead and do the quail eggs, the same process. That's not right. Wrong number. .34 times 438 is 1,024.92. And that's right. 2.34 times 12 is 28.08. And we'd have 2,340,000. Okay. All right. So that's the data table. Now, have you ever bought eggs at the store? Like there's small eggs and jumbo eggs and extra large eggs and medium eggs. So these are all kind of average numbers. But does it work pretty well when you're talking about millions of eggs? Absolutely, it does. So let's look at this ratio, the number of eggs. If we use these numbers right here, we're going to have 1 to 1. We're going to have 10 to 10. What does that reduce down to? What does 10 to 10 reduce down to? 1 to 1, right? Because if it's the same number on both sides and we are dividing them as a ratio, 438 to 438 is still 1 to 1. A dozen to a dozen is 1 to 1 because I have the same number of eggs. I am counting them in a survey. But the next column says the ratio of masses of eggs. So they did chicken egg to quail egg. How did they come up with 16? And this is math you probably can do without any kind of teaching. They divided it, right? So we start out with this number 374.4 to 23.4. And let's bring in our calculator again. And we have, see if we can make it a little bigger. We are going to have, so they did 37.44 divided by 2.34. So we're going to go 374.4 divided by 23.4. Let's try to get that on there. It's not going to work. So 374.4 divided by 23.4. We got 16 again. So it's 16 to 1. What do you predict it's going to be when we do 16,398.72 divided by 1,024.92? What's your prediction? Well, let's find out. Okay. So 16,398.72 divided by 1,024.92 equals, well, look at that. It's 16 again. So even though these numbers are very different, the ratio of masses between the chicken eggs and the quail eggs is still 16 to 1. Okay. So we'll go ahead and do the dozen, but what do you think is going to come out? What is going to be the ratio when we do 449.28 divided by 28.08? 16 again. So this is why we use moles, because the ratio, when we're looking at a chemical equation, we need, for instance, like it said in the paragraph up here, it talked about water. If I need 2 moles of water, or 2 moles of hydrogen and 1 mole of oxygen to get 2 moles of water, then I can use the masses in order to get a 2 to 1 ratio in my chemical reaction. So this last one is also 16 to 1. Okay. All right. So what is the mass? Go ahead and answer these questions for number 1. And we already did number 2 together. So go ahead and answer the questions in number 1 as a sentence. So hit pause here and answer the questions. I'm going to give you about 2 minutes. All right, so let's go ahead and scroll down to 3. And we're going to use the data that we just looked at to answer the questions in the third part here. It says, imagine you have 2 baskets, one filled with quail eggs and one filled with the same number of chicken eggs. Which would be heavier? What do you guys think? In the chat, you can answer too. Well, you got to go back to the math. You got to go back to the data table. Which one's heavier? The chicken egg is heavier. So there's your answer. But then, how many times heavier would that basket be? So remember when we were filling in the table and we said, what do you predict? A dozen chicken eggs to a dozen quail eggs, the mass ratio is going to be. So does it matter if it's 1 or 10 or 438 or a dozen or a million or a mole of eggs? What is the mass ratio of chicken eggs to quail eggs? 16, right? So that's how many times heavier that basket would be. And then you can go ahead and answer C on your own. All right. I'll pause for a second while I hear typing. All right, so number 4. A farmer weighs out 32 kilograms of chicken eggs. What mass of quail eggs would he need to weigh out to have the same number of eggs in both samples? So let's go back to our data. We have 32 kilograms of chicken eggs. How are we going to figure out how many quail eggs we need? What do you think? We're going to use that ratio. So if for one chicken egg divided by 16 gives me the mass of 1 quail egg, right? So I'm going to use the ratio. I'm going to divide by 16. And conveniently, I think they probably knew this when they made the paper, a farmer weighs out 32 kilograms of chicken eggs. If I divide 32 by 16, what am I going to get? Oops, hold on. Now, kilograms, notice, is what they ask us for. But if the farmer had weighed out 32 pounds of chicken eggs rather than kilograms, what mass of quail eggs would he need to weigh out to have the same number of eggs in both samples? Is that just as easy? Well, I'm going to make this answer pretty easy for you. I'm going to say we would need to convert the units, but the mass ratio would still be the same. Because a pound is different than a kilogram. So you might have a different number of chicken eggs to start with. All right. So this one's a thinker, this last question. A farmer makes up a new counting unit called a cluster. If the farmer had 3 clusters of chicken eggs and 3 clusters of quail eggs, what could you say about the ratio of their masses? Now remember, this is a counting unit. So if I'm counting them, is their ratio of masses still going to be the same? Let's use the evidence we've already had. We said it would be the same in this B here. It was the same every time we did the math. So is the ratio of masses going to be the same no matter how many eggs are in a cluster? Yeah. A cluster could be who knows what, but it doesn't matter because a chicken egg is still 16 times the mass of a quail egg. Okay, so answer A and B, and then we'll move on to the next part. Hopefully now we can take what we've thought about eggs, because eggs are really easy to visualize in our head, and apply that to atoms. Okay, we're going to apply it to atoms. We're going to use the same kind of concept, and we're going to use and it actually gives us a lot of the information. So same thing. I want you to go ahead and fill in the data table. I'm going to fill it in too, but take a few minutes and fill in the data table on your own, and we'll make sure we come up with the same answer. All right, so hopefully you used what they gave you there with the 16 AMU and the 32 AMU, and it made it pretty fast for you. So 10 atoms of oxygen would be 160 AMU. A dozen atoms of oxygen would be 192 AMU. A million would be 16 million AMU. A mole, we put it into grams, so it'd be 16 grams. So it translates directly from AMU to grams when we have a mole of them. That's the big takeaway from this assignment. And then sulfur, the same. The masses, though, is a 1-to-2 ratio. Okay? So then you can go ahead and kind of fill in 6. I can't. Somebody's talking. I don't know who. Whoever just said something, it just sounded like mumbles. I didn't have the speakers up. Can you say it again? All right. So fill in these answers. Okay. And go ahead and fill into 11, and then we'll come back together and talk about it. You probably have a little bit of time to think about these questions to 11. I wanted to touch on number 10. It does talk about that pounds example again. So if we kind of think about it, let's kind of think through it. 16 pounds equals 7,257.48 grams. 32 pounds equals 14,515 grams. So after converting that, even if I look at those, they still make a 1-to-2 ratio. So when I do that division, if I said 14,515 divided by 7,257.48, I'm going to get 2.000. You see, there was 5 zeros, 55116. So I'm still going to have a 1-to-2 ratio. So the number of atoms are still going to be the same. So just kind of confirming, compounding, making sure the ratio of the number stays the same. The mass ratio stays the same as well. So, all right, we didn't do the in front of the room thing for you to see that, but if you move on down to the next part, we'll kind of talk about this for just a few seconds, and then we'll turn in what we get to today during the class. So it gives you average mass of a single particle of all these different things. average mass of 1 mole of particles. Notice they're the same things: hydrogen, copper, oxygen, water, and sodium chloride. Okay. So look at the periodic table. What number in each element's box would a chemist use to find the values of the average mass of a single particle? What is that? We've already talked about that. We already know that one. You're going to use that bigger number, the average atomic mass, for that one. How is the mass of a... So I'll give you a second to type that. And then 13 here. Really look at those numbers. What's the difference between the average mass of an atom of hydrogen and the average mass of a mole of hydrogen? That unit is really different. So I'm going to even type this in here for the video. The unit. Because at AMU or atomic mass unit directly translates to grams per mole. Okay. So when we talk about, this is important, and the reason I did this whole worksheet was to point out this unit business, because atomic mass unit is one atom. Grams is a whole mole of them. So when we get into these math problems and they're really complicated and have a bunch of steps, the units just become so much more important. So please make sure that you're looking at the units when we're doing these problems. And this is a question right here that you're going to see similar ones to over and over. So let's talk about it. Which sample contains more atoms? 18.016 AMU of water or 18.016 grams of water? What do you think? The AMU is one molecule of water. The grams is 1 mole of water. So a mole of water is 6.022 times 10 to the 23rd. That's the explain part. Okay? That is the explain part. So you need to really get that locked in. Okay? So then the last questions are practicing finding molar mass. So I'd like for you to do that, and you have about 6 minutes to do that. So go ahead and do that. Finish those questions to 17. Don't worry about anything past that. Don't worry about 18. Just finish to 17 and then submit the paper. Okay, so submit this. If you've done it in your notebook, written out all this stuff, then just take a picture of your notebook. If you've done it on Cami or DocHub like some of you have, then just submit that as a PDF with your annotations.